Hey guys, day 2 of Unit 7, Gene Wells here. Starting off with number 2, it says if 3x plus 2y equals 4 and negative 3x plus y equals 11, we got to find the values of x and y. This time it's not substitution because I have two equations. I noticed that neither of them are equal to the same thing. I also don't have x by itself or y by itself. So today in class we worked on, well, the first thing we should do is to line them up on top of each other using like terms. So we make sure that we have the x's on top of the x's and the y's on top of the y's and the numbers on top of the numbers. Like that. X's are lined up, y's are lined up, equal signs are lined up, numbers are lined up. Then we look and see, is there anything that we can cancel out? Eliminate. Well, yeah, the 3x and the minus 3x, those are opposites. Opposites go away or cancel. So those cancel out, and then we can just add the rest of this equation together. 2y plus y is 3y. And then don't forget, we're also going to add this 4 and 11 together, and that will give me 15. And then we have a simple one-step equation, divide both sides by 3. We are left with y equals 5. Now remember, we're doing systems of equations, two variables, so we still have to find out what x is. So I'm going to take this first equation here. I'm going to write it down. 3x plus 2y equals 4. I know y is 5, so I'm going to replace in this equation my y with this 5. So I've got 3x plus 2, and instead of writing down the y, I'm going to replace it in parentheses with a 5. And then I'm just going to keep going here. I've got 3x plus 2 and 5 is 10 equals 4. I'm solving an equation here. So I'm going to subtract 10 on both sides. So 3x is a negative 6. Divide both sides by 3. X equals a minus 2. And now I have both my variables. Y is 5, x is negative 2.
Alright guys, for practice problem number 5, it's not so cut and dry, because as you can see, they're already stacked up, which is great. However, when we look at it, nothing can cancel out at the beginning. We got a negative 3x and a negative 3x. When I combine that, I'm going to get a negative 6x. That's not going to work. Same with a negative 2 and a positive 1. I'll end up, when I combining it, getting a negative 1. So I have to do something to one of these equations. And what I like to do is I'm thinking, which one is going to cancel off the easiest? And I'm looking at my coefficient with my x's, and you know what? They're the same number, but they both have the same value. I got to make sure that one of these is positive. And the best thing to do for that is just to multiply the whole entire equation by 1. So I'm going to take the top equation, and I'm going to distribute a negative 1 throughout the whole entire equation. So negative 1 times a negative 3x would give me a positive 3x. A negative 2y times a negative 1 will give me a positive 2y, and then a negative 1 times a negative 4 is a positive 4. So pretty much what I'm doing is I'm changing the sign for each one of these terms. Okay? So now that I have them stacked on top of each other, or pretty darn close to it, alright, now I can start to eliminate. And I can see right from the get-go, and the whole purpose of this was for me to cancel out my y's, or I'm sorry, my x's. My negative 3x and my positive 3x cancel out. I'm going to combine my positive y and 2y and get 3y, and then combine my 11 and 4 and get 15. Alright, good old-fashioned equation. Draw my river, one step, divide both sides by 3, and I'm going to get y to equal 5. Alright, now that I have the value of y, I'm just going to plug it into one of the equations. I'm probably going to choose the bottom one here, because it looks the most easiest. I'd rather do that one. So let's see, I'm going to have negative 3x plus y equals 11, and I'm just going to plug in my 5 for y. Still solving here. And let's see, I want to get rid of that 5 by subtracting 5 to both sides. That cancels out. I'm left with a negative 3x equals a positive 6. Divide both sides by a negative 3. and you should get x to equal a -2. Okay, so just remember, guys, when we go back up and we distribute that -1, to change that equation, we're no longer using this equation. We're now going to be using that one. Okay, so don't forget, once we distribute that -1, get rid of that top equation.